Okay. Good morning, everyone. I'm happy to open this morning keynote speech with two speakers, Pascal Hubert, who's a program director at AFNet, and Thierry Cormenier, who is standardization manager at Schneider Electric. And they will be presenting the Atlas program with a focus on digital twins for a systemic circular economy approach. So the floor is yours for the two presentations, and after we will have time for a discussion, an open discussion. So be prepared to ask questions.
Okay, thank you. Thank you to invite me to present the Atlas program. So I'm Pascal Hubert. I'm formerly a software engineer, and I become a system engineer during my experience. And since 14 months, I'm part of AFNet service, and I do some management of domain like engineering system engineering, digital twin, smart manufacturing for a very big program, which is Atlas program, which has been funded from the French government. So I will try to have some explanation on what is the Atlas program, and what is our strategy for the digital twin domains, and have some few examples of could be the use of digital twin for the circular economy, and this is a crucial things for industry for now. So what is that Atlas program? So 4 years ago, there is 4 associations in France. They are discussed together, and they said that we can answer to the French government call of projects on digital continuity and digital standardization. So in 2020, they build this program, and they win the program. And so AFNet, which is my association, MIND, which is an association concerning the building sectors, and the AFIS, which is the Association of Française d'Ingénierie Système, and Alliance Industrie du Futur. And we are all working in coordination with the AFNOR, which is the Bureau of French Normalization, because we are working in the field of standardization. One rules of the Atlas program is when the industry give €1, the government give €1. So it's very simple. Of course, there is a duration in time. During 3 years, I will give some money. The industrial sector gives some money. And of course, it is up to €5 million during all the program. So, but it is a very big opportunity to work together and to work inside all the ecosystem of standardization. For this program, we are at the service of all sectors, all industry of France, and we wanted to have some point on different key point as industrial efficiency, business skills, and also sustainable development, which is the subject of this presentation. Of course, we said that digital data, digital processes will not give us some opportunity to have a few frugality of data, but we have to think about that, and this is one of our guideline in Atlas program. So today we have already many companies that follow us. We have 16 sectors of industry, over 19. So we have a lot of people in France at the managing level, at the top level, which agree with our program. And we have already more than 34 projects that we are underworking. So we are promoting, as I said, the interoperability and digital continuity, which is two kind of things different. We are promoting the mutualization of effort, of industry effort. That is also our weakness, because we are looking for several companies which has different business objectives, but same processes to develop. So we try to have a mutualization of resource. And for them, our argument is that they save cost and risk to have a unique opportunity to collaborate within this ecosystem. So as you see in this field, we have 8 sectors, 8 domains, which is a PLM, system engineering, smart manufacturing, logistics and supply chain, maintenance, digital twin, the subject of today, data infrastructure, and building infrastructure modeling, which is for construction, building sectors. For the digital twin, our industrial leader is Thales, with Bernard Kent, which is a technical director of Thales, World Thales. And we have also his Sherpa, I will say, which is also a director, but Jean-Luc Garnier, which is also the president of AFIS. And myself, which who direct all the projects of the few projects of this domain. I'm also, as I said, to somebody managing the system engineering domain with Jean-Luc Garnier for AFIS. What are our projects and how we run? We have 4 kind of projects. We define the strategy of the domain with industry, and we help the industry to set up how they can use the standards and how they can use interoperability, digital continuity in their ecosystem. When we are set up the strategy, we go on the standards, so we can write standard, we can write pre-standards, we can write some technical report, and with them, and then we have to exercise the standards within interoperability forum, where we consider 2 groups of working, the user group and the implementer group. So the user group gives some recommendation and use case of the standards, and we wanted to the implementer or the editor for software to implement the rules that we wanted to have in the software, as for example the 3D experience of data system. And then we go over the deployment support. So we try to have some training, we try to have some proof of concept of many standards, and we go inside the company to build them. Today the Atlas program is followed by 3 committees. 1 strategic committee, which has been which is led by the sectors themselves. The program committee, which follows the duty of the project and all the money we spend for this program. And we have 1 scientific committee, who some people of this assembly is member, and we try to have some connection with the academic point for digital continuity and standardization. It is not the easiest to do, of course, but we are on the way to build some things. So Atlas program is a 3 years program first, but it will not finish after these 3 years, because we are all here and we construct all the ecosystem to work with standards and digital and interoperability. So, and all the project will continue after, but with more industrial funding and less government funding. So just to say that we have some assistant deployment, production, monitoring of standards, and we're setting all the necessary lobbying. You know that when you are up to this level, international level, we are to convince all the people that we have the right thing to do. We do the right thing to do, and the other maybe not. And we also manage all the ecosystem of expertise in France and try to connect people between them. We have some plan to co-build and amplify the know-how of several companies, and to build all the projects that we have in our field. Now I come to the digital twin domain. So last year when I come in AFNet service, we just start from zero, I think. I don't know many things about digital twin from my side. I was coming from the system engineering part, and it was naturally going to this new concept and new technology. Thales was beginning since 2 years to think about what he can do with digital twin for their business. And so we are beginning to think about many what will be digital twin for Atlas. So we have managed that digital twin is very transverse to other Atlas domain. We can find application of digital twin to all domain. We can support product life management to be able to have the digital thread over the life cycle. We can support smart manufacturing to build some agility for the product line manufacturing. We can support logistic or maintenance to build some enabler for training and efficiency and operational activities. System engineering could support the digital twin because we need some engineering collaboration to set up in digital twin. And for data infrastructure, we can imagine that maintenance could be set up with the digital twin of all the information system. And for building information modeling for the building sectors, there are very huge events with modeling, but they don't look at so much at the service they can do with digital twin. So with digital twin, we can define the service for the end user and not only for industry. So that we have defined 4 kinds of direction. So first of it is to connect all the industry between them, as they have many initiatives that going on, and the diversity of initiatives is very large, I will say. We are also one way to report on all the digital twin technologies that we can use to build digital twin. So you have the IoT, of course, but you have many things else, other things. One thing that we have to set up, and it's big things to do, is to contribute to the standardization of the life cycle of digital twins. A digital twin is an entity to develop, and we have to apply engineering to develop a digital twin. But up to now, I didn't define what is a digital twin. So we will see that maybe after. And of course, one thing, and not the last, but the best thing that we have to do, and it is to identify what is the added value of digital twin. Digital twin today is a buzzword, but it is also a very young research and very young technology or some things. It exists since 2000, and maybe people said the NASA has invented create a digital of Apollo mission, but it was a prototype of the Apollo mission that we need for space mission, as every space mission. But they can reproduce the life of the Apollo dysfunctioning, and they save all the astronauts like this. So we are thinking about one mission here. And what is important for us is to give sense to digital twins, and there will be many sense. Here some lines that you know. Digital twin is a very growing part on industry. Many company target that they will make a lot of money with that. And there is a lot of research and in technology involvement in this field. I just make a lens report just before last week, and I see all this paper published. For project, Atlas project, we plan to develop with Thales some digital twin related term and concept based on standard and industry initiative. We wanted to have going toward the classification of digital twins. It is very important to architectures the digital twins. We do have to make architecture, system engineering maybe, over engineering also. And we have to analyze what are the use case. And this is the only way for me that I think that we could address what will be the added value of digital twin on the life cycle phase of product system, service, and etc. So now I will take two examples of what I see on the application on digital twin in industry. And you will see that the work is very complicated to do. First of all, I think we have to differentiate three pillars of digital transformation. You have, of course, the digital part of a digital product, of a physical product. When you have a radio and it was analogic 40, 50 years ago, you came to a digital radio, but it is a transformation, a digital transformation, but it is not a digital twin. We think that digital continuity is not a digital twin, but it is part of the problem. But digital thread is a way to exchange information between different disciplines of the same product. And you have it on all the life cycle of the product. But it is only, I give you something to let us, that the next discipline could do this work. So the digital twin, for us, we will try to consider it as a double living of an entity of interest of a digital form, in a digital form. The very general part, but we have the same mission with the digital twin for the digital, the physical part of the digital twin, but we have to imagine that in a system of systems with the same mission. Of course, services can be imagined without a digital twin, but if you integrate digital twin inside the service you imagine, you have to consolidate it in a system of systems to have interaction between the entity, operational entity, and the digital twin. And we have many surprises when we analyze in this way what could be the added value of the digital twin. Some characteristic of digital twin, it is an entity, it is a concept that we know that we need to have at least 4 characteristics: a description, an up-to-date state, a behavior that we can simulate or for diagnostic and prediction, and of course sharing. If you don't share your digital twin, you will be alone to use it. And apart the simulation that you can do alone, it will not serve the company of your and the business of your company. So we have to notice that it is working in a complementary way of the operating entity for an operational, economic, and other gains. We have to set up what are the mission of the digital twin in collaboration with the original entity. So I take one example and after another example for the aeronautic sectors. I just read at the beginning of the year one French government report, and today on the 46 proposition that they need to have, at least 70% of the proposition concern the low carbon objective. So the digital aid, the digital help that we could have for aeronautical sectors is really oriented with the low carbon sector, with the circular economy. So the operational declination of what we have to imagine is a digital continuity and digital twin. So digital continuity, I take the life cycle of a motor. Okay. You all know what is the life cycle. I will not describe it all the time, but we set up, we have a lot of discipline, and you can imagine that you can work on design, on verification, on production, and also on dismantlement of the motor. This is the digital continuity of the system. And we have to know that all the engineer going with his specialty needs to have input to work. And he receives some files, some input document to work. So today, when we imagine digital twin, I think you don't see what's happened here.
Pourquoi ça marche pas? I'm sorry, just a technical.
So we follow like this. So I was on that slide. Sorry for the technical problem. So when you imagine, so I was on previous slide, digital continuity, you have the motor, all the disciplines that specialties that are working on the motor engine of airplane. And when you are making some digital continuity, you are working on all the cycle of the life cycle, the product life cycle. When you are making digital twin, you take one specialties, one fields, and you have you are making some digital application to help you to make the mission of your airplane. Here, for example, I show you a map of all the flying airplane, and you can see that there could be many information coming from the airplane that help people to make a mission and to be operational. And you can imagine digital twin for all other specialties, which are very independent of the others. And after, people said that you have big company like Accenture, Capgemini, that said that digital twin is a disruption of all the company. From my side of view, I will say, let's do one part of the flower, and let's going on, and let's going on one part of each life cycle of the product, and then you will begin to do some things. So you have all the things like this. So when you have detail for engine digital twin, you have an engine is very complex things. You have a lot of physics inside. You have a lot of electronics. You have a lot of software, and of course you have a lot of people working on it. So the complexity is not only due to the product itself, the system itself, but also for the governance of the work product. So here I give you some examples that I see in the literature very recently to make a mission of engine digital twin. One other example is for building construction sector, building sectors. There was some, of course, building sectors is very complete. Takes a lot of time to construct a building, and people that make models of buildings takes a long time. And today, building information modeling is one technology which renders the circular economy possible for this kind of sector. But even it is a sector which is really in advance, there are still some big issues to do. When you are on the field of construct building, it is only paper that people bring with them to exchange information, and they lost a lot of time to reconstruct all the information for that. So that one of the missions that the sector is doing is to construct a dictionary of terms that people can exchange between them. And of course, they need to put it on a platform to be able to exchange the real information between all the people. So there was a Boost Industry platform that can be done. And now there is some important feature concerning European, because they need to go ahead with circular economy, so to imply more decrease of carbon consumption, and they notice that construction is part of 30% of the carbon emission in the world, and they need they analyze that they need 50% during the construction phase and 50% during the operation of the building. So that they imagine some action in the renovation, but because we have a legacy, as in information technology, you have a legacy that you have to treat with a lot of consuming of energy. And they are reflecting of, or they have to destroy all the things, or they have to make more flexible artifact in the building. They are also reflecting of digital twin to help waste management, and of course zero pollution. So with these two examples, we can see that all the sectors are beginning their work very hardly, and we try with Atlas program to mutualize all these initiatives and to try to find some not unique way to build digital twin, but to offer to each specialties a field to with a cross-fertilization of their initiatives. So thank you very much. So I will let Michel present his presentation, and we will be happy to answer your question after his presentation.
Alors du coup, j'espère que ça va mieux marcher qu'avec toi, qu'avec moi. Donc c'est la deuxième. Du coup, on va la remettre comme ça. Et là, je te mets en présentation. Voilà, normalement, ça doit être connu.
Ok. On revient avec les flèches. Ouais, comme ça. Ok.
Hello, everybody. First, thank you to have been invited to present the I would say, the journey also of the digital twin. To introduce myself, Thierry Cormonier, Schneider Electric, energy management, not industry automation, and mainly power system. I work mainly on standardization, IC, and compared to ISO. And roughly, I'm a member of the 15 working group and a convener of the environmental aspects and also that the catalog data. That's why, in fact, that the both digital, green and digital. That's why. And recently, in fact, I joined also that which would be interesting also, that the Standardization Management Board of the IC for the CO2 data along the life cycle. That's why it's an important topic, especially due to climate change. Digital twin in a systemic circular economy approach. In fact, I will present that first, that the link with sustainability and digital twins, then a short discussion about structuration of the digital twins, and also that what is happened related to a circular approach, and also a very important things about the durability, because without durability, why you have material circulation, if you have no issue of durability, and also property for waste management, and conclusion. First, this one, the 3 pillars of the sustainability. Very often you can see, and even in ISO, because ISO on the TC 323 starts with this, but you can see that economical aspect, social aspect, environmental aspect. However, I would say it's a pity, because in fact you have the users. And it's very important, in fact, to introduce the 4th pillar, which is technical. It could be obvious that to say, okay, this one is already identified, and we need the others. Yes. But in fact, in optimization, we need to consider the 4th aspect. It's very, very important. Due to this, in fact, that in Europe, currently you have a set of standards, the 45550X, and in fact, but it's in silo because it's all assessment of durability or recyclability. And this is the reason why that the Sensenelec GTC 10 starts with a working group, the working group 8, dealing on circular design. All of these aspects are obviously linked to the United Nations Sustainable Development Goals. But this one is important because one of the discussions was how to convince the policy makers, because in fact they thought about that the requirement in silo. However, any optimization, you need to catch the global view. And it's very important. That's why we took that this is not new for you, especially in automation engineer, as I saw this morning. But in fact, it's just to remind that when you have unknown parameter of the function transfer, it's very interesting to set the order to the real system and to the digital twin, to the model, to the digital model. And in fact, that the closed loop feedback, in fact, by the difference of these two answers, is typically the adaptive control system, and it's not new. That's the reason why the digital twin is contributing for this one, and you will see that why we need, in fact, that the complete view to drive an ecosystem. Because when I read the Circular Economy Action Plan from Europe, it was clearly mentioned. I asked the researcher to modelize that the planet and the ecosystem, how you are able to carry it out every day. In fact, they are looking for to find solution, how to do that. And in fact, if we are not go outside of the box, in fact, like to think differently by innovation and so on, in fact, I'm not sure that we will reach the target. Now for the construction. And again, we wrote a lot of articles about digital twin, energy management, and so on. And what is the definition? And in fact, by ISO IC, digital representation of a real-world entity or system is obvious for everybody. However, in fact, when you, I prefer to start by the highest level that I'm completely saw this morning about that the interest of the digital twin to anticipate, to simulate, but at the end, in fact, to be autonomous. However, to carry out this one, you need to be able to fully controllability of the system, okay, which is only possible if you are able to decide. In fact, that's why you need the decision making. And for your information, the Sustainable Product Initiative written by Europe mentioned decision making, but not only decision making of the system, is also decision making for the user, because the Europe push the regulation for consumer goods. I'm convinced about industrial, high level, airspace and so on. In fact, they have this level. However, 90 sometimes, some groups of Europe, 90 experts, no skills about industrial aspect. It's a nightmare, but in fact, believe me, I wrote 80% of the document dealing on durability assessment for Europe, for all products. But in fact, we currently, the message that I invite the industrial and all people having the skill to go inside the standardization working group to write what it would like. Because otherwise, in fact, again, to reach the target is really important to promote that all the skills you have, especially inside this room. Data and analytics, for sure, that by observability, because you need that the environmental condition, because you need the mission profile when you design a product, and by environmental condition and operating conditions, because why you speak about durability if it's not related to the conditions? Many of quality issue and so on is related to the, I would say, missing or to have a gap between the design stage and the use phase. That's why it's really important that the manufacturer has also to communicate that. But for sure, that environmental and operating condition, if I compare to an aircraft, it's typically like some of IC standard remove some aspects from the standard. Why? Because in fact that I would say environmental aspect and other is less affecting that what it's happened for an aircraft compared to another product. That's why it's really important also that to consider that. Service and service condition is really important. Okay, that's why I mentioned environmental condition, and also this one contribute, all of data contribute to manufacturing phase. Okay, but you need also that to consider that the manufacturer model, because you mentioned Industry 4.0, for example, along the supply chain, it will, asset administration chain will be retained to vehicle the CO2 data. However, for energy management, in fact, at the use phase, for an electrical product, mainly this one is coming from use phase. But is it the model of asset administration chain? No. It's a common information model, is IC 61850. You have other models. That's the reason why the interoperability must to be applied along the life cycle and also between the different tools and the different infrastructure. That's why this one is important, because all of them has been defined by the standards, while I would like to come back again by the function. Without function, you have no product. That's the reason why we have to have a clear surrounding of the function identification. Very simple. This one is just to remind that just reminder that digital twin or data contributing to the digital twin start and born at the early stage of the design. But what is missing usually? When people focus on products, they forget that the system, any product, even consumer goods, are used in your system. Where you make your private decision for your product. In fact, you integrate your system. And this one is part also of the decision. That's the reason why it's very important, in fact, to focus on this one. And the different color shows that we have to optimize the use phase. Otherwise, in fact, you reduce that or you increase that the environmental footprint, I would say. That's the reason why more and more you have durability, longer lifespan of product, extending the lifespan of product, and also refurbishing, action of both maintenance, repairability, and more, in fact, you are far from this use phase. In fact, you increase your your environmental footprint. I work also that, just a reminder that one of axes of the classification, because you have a lot of property, like I would say, imagine like your data lake and so on, but how you classify this one? Because in fact, one axis is for one model, another model, you have different model. And never you will have only single classification. To be honest, when we wrote on the catalog data for AG switchgear, I took an example, rated voltage. You know how many times the rated voltage is defined in electrical world? And this is the reason why we use, as a protégé, we use and we built an ontology about rated voltage to be able to communicate between the different models, because different product, the technical committees of the IC or other organization, in fact, that you have to be able to communicate. And in fact, it's not that the top-down approach. Never you will have that the one model or one dictionary better than the other one. Tomorrow you will have US, China, and typically for material declaration, typically giving an example, this one came from IC. ISO decided to embed this one, but it was the 62474, which become now 82474 at ISO, embedding now by the link in US and so on for aircraft. And now Dassault System is managing this group. That's the reason why, in fact, all of people work all together to have, I would say, one of the best. But at this, except this one, in fact, imagine the story, because it's 10 years ago. Okay, that is started for material declaration. That's the reason why never, if you start and accelerate the digital transformation, we need to have a bridge, I would say, a semantic bridge to be able to move from a model to another one to ensure that the interoperability. Focusing more on the circular economy, this one is just a very rough and macro approach. I will discuss about value management. Value management. All of our presentation I'm seeing currently is value management. When I said, do you have the definition of value? And in fact, ISO starting ISO 56000 by innovation, reuse the definition defined by Europe. And I invite you that on my website to check value management handbook. The book at 26 years old, in fact, and in fact, is at the origin of the current standard dealing on functional analysis and value management. And you will see that by anticipation, they have already a lot of answers inside. That's why also that I'm presenting, because nothing new. In fact, it's just to adapt that the right tools to the right needs, I would say. That's why I will reuse that this figure at the bottom on all sides, in fact, of slides, to identify where, in fact, you will be for the next stages. For this one, you have that the need to the value management. Any value management, you need to have life cycle thinking, because you have to integrate that along the life cycle of each life phase, all of stakeholders' requirements, okay, considering their environmental conditions, okay. And what is after the functional analysis? The main pain point when you have that the functions. The issue, each time the question is how I'm able to run the function. I remind the pyramid, controllability, decision making. If you have, for risk assessment, if you have not able, in fact, to have the ranking and to classify your function, how you make decision. And also that for the same application, it's really important to consider that two users on same application could have two different hierarchy of functions, because their DNA of the company could not be the same. Okay, did you remember also the 4 cycle, economical, social, environmental, and technical? That's why, based on this functionality, in fact, that is not, I would say, homogeneous compared to different companies. That's why any device, automation device, working on the decision-making for controllability should lead to the user the flexibility to decide about the priority of its function. And currently, even in our company, and sometimes is not done. And that's why it's very important to consider this one. This one is just also because a lot of working, just to remind that a lot of communication about use case. As soon as you are going to digital, in fact, is use case. Nice, but by definition, use case. Specific. It's specific, sorry, and it's not global. That's the reason why use case can complete global, but you need to start by the global. And the global, functional analysis, all stakeholder, all life cycle, classification and function. And after, for specific use case, for sure, we have additional properties and completing that the model and so on. But it's when I'm seeing that how to design a model based on use case, I'm sorry, I'm a little bit afraid, because I need the global approach. This one is an example, because I didn't carry out all of the functional analysis for circular economy, but has a lot of there is a lot of communication about this one, and Elaine MacArthur, European Environmental Agency, IC Guide 109, interesting, and also that working group dealing on material efficiency, and also ESPR is the Environmental Sustainable Product Initiative and Regulation, which arrives. In fact, there is a proposal, and again, to not forget that the customers' values on the material efficiency, because again, we have to introduce this one. That's the reason why IC Guide 109 is very important, because in fact, you consider that the function on the left part, that's what for, and how to. That's why again, you have user function, the needs, and how to, the technical functions. Not merging both. That's why. On ESPR, that's a proposal coming from Europe and under watch, I would say, and for comments. Many things identified. I didn't repeat that all of the lists, durability or reliability. However, a new item is the CO2 footprint. This one was not defined previously, especially on ERP. ERP is the Eco-Design Directive for energy-related product. That's why you have a lot of requirements asked by the European Commission about that those products for energy efficiency, but you have the tool. But what is mentioned on green, eco-design with no adverse impact on health and safety, no significant negative impact on functionality. This one is just to remind, we never without global approach and digital twin, this one could happen, because we need the global view. And at the bottom part, digitalized, accessible through free access website or application before procurement. This message is clear. In fact, it will be related to the digital product passport. Okay, and machine readable, interoperable. That's why the European Commission heard clearly that all of papers and so on. But the message by requirement is, I would say, very clear. Considering all of functions, in fact, this one, if I'm going to too much detail on the left part and enough, I would say not or unclear on the right part, in fact, by the gray zone, in fact, we selected some product. Giving you an example, I need repairability. Yes, but the standard mention how many tools you need, the time, repairability index. To be honest, for the user, if you think user, the only thing is how to extend the lifespan of my product because it will be repairable. This one is important. But how many tools? In fact, yes, it could impact that the repairability index, but when you compare the function for your hierarchy of function, it's too much detail, I would say. That's the reason why, in fact, selecting this one, we made simple calculation, those classification, and very obvious for you. And in fact, we arrived to this one. And is only an example. If you carried out this one with another projective and so on, you could have another result. What it's happened at the top level, avoid any injury by design over the product lifespan when used under specified condition. I think this one will be applicable for a lot of products. And the last ability to be energy recovered, that's why is just before, instead of landfill, you are going to burn your product, in fact, but you need energy consumption. But in between, you have a lot of functions. When I focus on those functions, in fact, I identify that related to the durability, you have a lot of things, and you will say the durability, the 10th first requirement, 67% of the first function are linked to the dependability. That's why reliability, durability, both. That's the reason why, again, environmental and operating conditions are very important. Again, the same, explaining why for durability, that the knowledge in this one, in fact, from my point of view, is not enough deployed inside the standard. It's still from the stress modeling. There is, I would say, improvement of the standards. Because of new material, as you mentioned, and so on, how this one will be when they are facing to special conditions. In fact, the damage modeling must be carried out, because if you need to anticipate the behavior of any material and so on, we need, in fact, to have the global model. And also environmental requirement is carried out when you carry out a life cycle assessment, and which could be up to LEED. LEED is, I would say, the most recognized green label for the buildings. as an insider, you have intensity, typically like near the track, where you have a very interesting results, interesting leads. And do not forget applicable regulations. CO2 is also a part of the picture because, in fact, that the weighting factor of the CO2 by Joint Research Center of the European Commission is 20%. That's why it's very important as an impact category. One word about the property for waste management, because very often we saw glass, plastic, paper, and so on. And now for digital twin, you have more like e-waste. An IC standard is starting about e-waste. That's why I would say battery, supply, and data. You have to manage the data. That's why the collection is really important, that the collection of material, part, and product, and their data after the end of use and end of life, both, must be managed and are key to transform waste into resource for other lives. I gave you that an HC standard, which is interesting regarding this process of data, because you have some link with, I would say, data security. Okay. In conclusion, UN Sustainable Development Goals associated to the technical function enable to the review for functional requirement for customer value creation, value key. Enrich the digital twin for sure that along the life cycle, but the focus will come from every time from the value management. Okay, applying I would say applying that the functional analysis, and do not forget that the classification of function. Digitalization will contribute, however, I would say environmentally conscious digitalization. Okay, not digital for digital. And that's why we will start it in IC working group, crossing data model and environmental aspect on the effect of the digitalization on environmental aspect. A special working group will start. And also that the decision making will be based on classification and function, and relevant digital twin contribute to vehicle the properties related to environmental performance of the product along the whole life cycle and for future lives. Thank you very much.
Thank you very much to both of you. Now we open up the discussion session. Who's ready to start for first question? There is a microphone over there. I don't. Oh, okay. And the other one, maybe I can also provide it if someone wants.
So thank you for your presentation. I have one question about the last part. You have this list of functions, and I'm wondering how company in the future will be able to verify that their solutions satisfy the function. So there is a missing part, which is the requirements derived from the functions. So there will be any guidelines, recommendation to derive those requirements, or will remain at the functional level that is without performance criteria, sometimes a bit ambiguous?
I think, as I explained, in fact, that never you will have that all fit one. And in fact, that what is important is that circular design, typically like all of this, like this presentation and the main part, I put already in I would say that the standardization committee dealing on circular design, because in fact that I have no royalty about this one. It's just to remind that the people writing standards, in fact, apply the right methodology. And typically, like you could have some requirement, but what it could be, it could arrive, and which would be a nightmare for industrial aspect, is just to have some requirement in silo. In silo, in fact, if you have some requirement, this durability is this year's, and you have material recycled content at this level and so on. But in fact, you lose completely the global picture. I will give you an example. The copper wire is not repairable, but is long lifespan. But how you deal with this one? And to answer to your question, in fact, we promote the methodology, and in case of certification and so on, it's just to have the right process, and considering that the stakeholders, the users, and the planet is one of the stakeholders.
Thank you very much for the presentations. I see there that the feedback from the operations to the is very important to maintain the digital twin. Do you see a need for synthesis? Because back to the knowledge management, to have it, you won't be able to. I don't think it's possible to keep all the information about if you do configuration management, and we already have some problems in the digital thread to keep that on the way down. How do you see it? Feedback from the field up to system design, as an example. Any plan for this, for circular economy, or yes, particularly?
Yeah, you're right, I explained. Part of the circular economy, I mentioned about durability. But the part you mentioned is already identified, is brought by IoT and a cloud calculation, both. But in fact, you need that the physical model first, functional needs, which is complete. Did you remember the pyramid? When you arrive on the risk assessment, you're right, but the field, all of the information coming from the field is already implemented. And I follow for more than 4 or 5 years that the IoT World in Barcelona, that's the global fair. And in fact, you have the answer. But you put IoT, but you have, as I mentioned, environmental conscious digitalization is not to push IoT everywhere because you have the idea. Because you reduce the reliability, more and more device, but you need to be accurate related to the IoT. But the field is considered in this one, because if you have no information of the field, how you could predict, like predictive maintenance without information, but you have a condition-based maintenance, and all of information is already integrated.
Yeah, my question had to do what kind of treatment of information that you need to do it properly. I think the value of digital twin is a big concern for everybody. When you need to find ways to have return on investment for people that are going to invest in digital twin technology. And if we have too much information and we're overloaded in information, it will not be useful. So how do you see this, I would say, this synthesis of information back into the design and the circular, I would say back is a good question. And are there any initiatives to clear use cases to test this in the future or in the coming years?
Durability is coming by, in fact, what is the definition? Is you lose the functionality. If you have the right sensors and right information, you know exactly that's the pinpoint, and you don't need a lot of IoT, a lot of information. What you need, in fact, is just to record environmental and operating conditions. These ones are very important. Because typically, giving you a transformer is a load at 30%. That's why all of the edging is not coming from the loads. Why you would like to follow the load?
I have 2 questions. This is a preliminary work, or do you have already digital twins running? And if it's the case, what is the form of these digital twins? Are there equation-based, simulation, stories, whatever?
I would say in Schneider, a very huge group. I'm confident that ontology started, digital twin started, EcoStructure, predictive maintenance start. In my case, this one is just to bring awareness of the standardization working group dealing on circular design, this one, and not reflecting that the company said or to sell product. It's just only to bring awareness to people which have no skills about this one. This is my answer. After, on I would say practical example, I convened a working group dealing on the catalog data for high voltage switchgear. This one covers 22 standards on high voltage. I remind that high voltage is also embedding SF6, which has the most impacting gas of having the global warming at the 25,200. That's why, in fact, we also address this one. And answering to your question, in fact, we have considering review of data, avoiding, in fact, to duplicate such data, that to be efficient, especially on one technical committees, and which are repeated by other technical committees. That's why we have at the bottom part of the pyramid While your question is after, I would say, on the highest level of the pyramid to other digitalization, asset management. But it's another part and is carried out inside our company too. But in our company, typically like smart grid management. Smart grid is a TC57 and working group dealing on automation of the energy management. But in fact, they didn't consider currently the data coming from the asset because they started 10, 15 years ago. And in fact, that the properties of the assets, power transformer and so on, were not defined. That's the reason why we need catalog data. Again, data, in fact, is like the fuel of the engine, as I mentioned. Without data, you can carry it out. That's the aspect of how to make a decision. And this is the reason why we need data. We need semantic and interoperability, but we need those dictionary. And after, this one will be deployed.
Okay, so, but data, I agree that data is the input. But what kind of models do you envisage?
Model currently at the common information model for EcoStructure. That's why all of dealing with like RTE and the company dealing with energy distribution, electricity distribution. You have the 61850 dealing with all protection relay and the control system with buildings, and also asset administration shell to vehicle the data. And after asset administration shell, we'll have the submodel to discuss with IC Common Data Dictionary, submodel to discuss with the IC 57. That's why asset administration shell is accelerating to create submodel. This is my answer. And currently, Schneider is, I would say, as a repository, push data to E-class because E-class is recognized by IC.
I'm sorry, but I see that time is running and the management is telling me that we have to close up the session. So thank you both, and I think you can continue the discussion. But before that, I have something, one duty complete. There is a little present for you from the organization. So it's something that I think you can eat with a good pleasure.
Thank you very much.
Thank you. Thank you very much, and see you after the break.